So today we're going to introduce you to what a system is, very basic, and then we're going to do graphing part 1 notes. So very basic systems, and then graphing part 1. So first we're just going to define what a system is. So what is a system and what is a solution? Okay, so a system, if you want to write this down, let me get my little pen there. Okay, so a system basically is two or more equations. Now in algebra we only have 2. Okay, we're only going to deal with 2 equations. Later on in algebra 2 you might have 3 or something like that. 2 or more equations. So instead of just having 1 equation, we're going to have 2 equations. Okay, that's all it is. System just means there's 2 equations. Okay, what is a solution? The first thing that we're going to do is it is an answer to a system. An answer to a system. Alright, but for today also, a solution is where 2 lines, because there's 2 equations, so you're going to have 2 lines, and it's where those 2 lines cross, or where the 2 lines intersect. Okay? Basically where they meet. So a solution is an answer to a system, or where the 2 lines cross. So we're going to go super simple and kind of back up from there. So let's say we have systems from graphs. Go ahead and just sketch this graph. It does not have to be perfect, but systems from graphs. So this is a system because there is 2 lines. 1, 2, 2 lines. And I told you the answer, the solution, are where those lines cross. So if I look here, those lines clearly cross right here, correct? Well, what point is that? Well, that point is 1, 2, 3, and negative 2. So my solution, or my answer, same thing. Solution would be 3, negative 2. Over 3 down 2. It's perfect. Okay? Very simple if you're given a graph. That easy. Okay? What about if you have tables? Just go ahead and pause and write these down real quick. So if you have tables, well, solution are where the 2 lines cross, right? So, but if you have a table, you can't really see where the lines are crossing. So it's where it has, let me write that. It's where it has the same point. That's where those lines cross, because if they both have the same point, they cross there. So this is negative 4, 6, and this is negative 4, negative 12, so that's not the same point. Negative 2, 9, and negative 2, 9, that looks good. 0, 12, and 0, 15, not the same point. 1 and 13.5, and 1 and 22, also not the same point. So this is the only point that they have in common, so that's my answer. So my solution is negative 2, 9. Alright, so yet again, really simple. It's where 2 lines cross, where they have the same point. Very, very, very easy. But what if you have parallel lines? Go ahead and sketch those. So this is a system. There's 2 lines. 1 line and 2 line. Okay? So if the lines are parallel, those lines will never cross. So what you need to know is parallel lines have no solution, because they're parallel. Okay, parallel lines have no solution. Real quick on the same aspect, what if it's the same line? So what if you go to graph an equation, just to show you. So let's say I was to graph something here, and I were to graph, 1 line, and then all of a sudden it graphs the exact same line on top of it. You can't even see it. If it's the exact same line, that's infinitely many solutions, or basically all real numbers. Basically means everything's a solution because they touch everywhere. They cross in every direction. So parallel lines have no solution. You'll see this a lot more. You will see this rarely, but if it's the exact same line on top of each other, it's infinitely many solutions. Okay? So there are several different ways to solve systems. So the first one we're going to be going over, it would be graphing, solved by graphing. The second way is substitution. The third way is elimination. And the fourth way is by something called a matrix in your calculator. Okay, we're going to spend some time working on all these, solving them all these different ways, but all of these are just 4 different ways to solve the same type of problem. Okay, so If I give you an elimination problem, you could still solve it by graphing. Or if I give you a substitution problem, you could still solve it in a matrix. There's just 4 different ways to do it, basically. And we're going to be focusing on graphing today. So, steps for solving systems by graphing. Now, if you have a graph, like, don't draw this, but if you have a graph and you can see, like, the lines cross here, you can see the solution. But a lot of times they just give you equations and you have to put them into the calculator. So, here are your steps for this. So, pause and write them down, please, but all these steps need to be written down. Step 1 is you have to write the system if you're given word problems. Step 2 is to solve them for y, whatever y is. Step 3 is to y equals in the calculator. And this is really where the calculator steps start. And you've done this before, it may have been a while. You put your equations into y1 and y2. You graph them. You make sure you can see where they cross, which is by zooming out. This is to zoom out. And then you press second trace 5, enter, enter, enter. You've done this before, but now we're bringing it together. That's a lot, I know. When we go over the problems, it'll be easy. So, let's go ahead and this is example 1. Y equals 8x minus 12 and y equals 2x minus 6. And I want to know a solution for that, to the system. There's 2 equations, it's a system. So, step 1 on your notes, you can see them, says to write the system. Well, it's already written, okay? I don't have any word problems. Step 2 is to solve for y. Well, I don't have to do that. I've already solved for y, okay? So step 3 is we're going to go to our calculator, and we're going to go to y equals right here. And it doesn't matter which one you put where, but I'm going to type them in. So I have 8x minus 12. I'm going to go down. And I have 2x minus 6. 2x minus 6. And then I graph. Now I need to make sure I can see where those lines cross. And I can. They cross somewhere right there. Right? So I don't have to zoom out. I can see where they cross. So I'm going to press the buttons. Second. These are straight off the notes I gave you. Second. Trace is right here. Trace, and you're going to press 5. And the reason being is because 5 says intersect, which means cross. So 5, and then I hit enter. Enter, enter, enter 3 times until it says intersection. And it says 1, negative 4. So that means that my solution, or my answer, is 1 comma negative 4. Let me tell you what that means, though, so you understand what we're doing. That means that if I type in 1, I'm going to get negative 4 for both equations. So just to show you, you don't have to write this down. Y is negative 4. So negative 4 equals 8 times 1 minus 12. Because x is 1, right? Well, let's see if that's true. 8 times 1 is 8 minus 12. And 8 minus 12 is negative 4. Okay, so that one works. That's good. Then here, y, which is negative 4, equals 2 times 1 minus 6, because the 1 comes from there. Well, 2 times 1 is 2, minus 6, and 2 minus 6 is negative 4. Okay? It's true for both equations, which is why it's a solution. It means a point that'll work for both of them, essentially. Okay? So, let's do another example. What is the value of x? Well, in this instance, it would be n, sorry, of n in the system of equations. So, step 1 says to write the system. Well, this is already written out, it's good. Step 2 says to solve for y. So you're saying, well, there is no y. You're correct, there isn't. But they're both solved for m, so if it really makes you uncomfortable, you could write a y here and an x here, and a y here and an x here. But you're going to see different letters being used, and that's fine. Just know that the y is going to be on the left side, and the x is going to be in the equation. Okay? So step 2, we're going to go to our calculator again. Go to y equals, I'm going to clear these out, and I'm going to type these in. So it says 2n plus 14, but I'm going to type in x. So 2x plus 14, and goes down, and then negative 6x plus 18. There you go. I'm going to graph it. I have that line there, and I have this line here. Now, I cannot see where those lines cross. I know they're going to cross somewhere up here, but I can't see it. So remember, to do that, you're going to zoom, and then out, which is 3. I'm going to hit 3, and nothing's going to happen, but you have to hit enter, and then it will zoom out for you. Remember, these lines up here mean it's thinking. So now I can do my second trace, 5, enter, enter, enter. Oh, I hit 1 too many times, sorry. Second trace, 5, enter, enter, enter. And I get 0.5 and 15. So my answer is 0.5, comma, 15. But it's asking which one is the n. Okay, so which one of these is the n? Because maybe it's multiple choice and they give you both of them. Well, look, n is where the x normally goes. So this would be x, and then the 15, that's the y value, is the m. That's y, right? So this is n, and this is m. So your n value is 0.5. Okay? Which is kind of tricky, I know, but you can get used to using different letters. Alright, so here's our last example. I'm not saying you have to write this down word for word, but listen to me and write down the important stuff. It says Darren owns a painting company that charges a supply fee of $50 and then $45 an hour. Kieran also owns a painting company that does not have a supply fee, but charges $55 an hour. So there's two different equations. How many hours would it take for them to charge the same amount? So this is a system, okay? So I'm going to write the first one. So I'm going to put Darren here. Darren, and this is like a little y equals equation here. He charges a supply fee of $50, so $50, plus $45 an hour. 45H, or X, or whatever you want to do. And then we have Karen. Oh, look, it rhymes. Didn't even plan that. So y equals Karen does not have a supply fee. So I could put 0 if I wanted to, but I'm not going to. But then also charges $55 an hour. So I'm going to put 55H here. So I have two equations, and it wants to know when they will charge the same amount, which is just the solution where they cross. Okay? So calculator. Go to y equals and clear this. Or let me back up. Step 1 was to write the equations on your steps. Step 2 is to solve for y. These are already solved for y. Okay, we'll get into the solving for y on part 2. Step 3 is to go to y equals and type them in. So 50 plus 45x, not h. And the order doesn't matter. See, I put it in y2. I can go up here and do y1. It doesn't matter. And this one's 55x. And I graph it. I'm going to see if I can see where they cross. So it's really hard to see, but there's a line here and a line here. All right, let's see. I'll try and see if it works without zooming out. So second, trace, 5, enter, enter, enter. Oh, it does it for me. It's 5, 275. So the point is 5, 275. But let's explain what that is real fast. This is the h, right? Or the x, right? And this is like the y value, okay? So 5h means what? It means 5 hours. So how many hours would it take for them to charge the same amount? It would take 5 hours. Do not, let me repeat this, do not give me this as an answer. That means nothing. If I say how many hours would it take for them to charge the same amount, and you put 5, 275, that doesn't mean anything, okay? It would take 5 hours for them to charge the same amount. And what this 275 is in 5 hours, they will both charge $275. And I could plug in 5 here for H and show you that. Okay? So, in summation, a system is two equations, and the solution is the answer to them or where they cross. You can see it in tables and graphs, and you can also find the answer to that system in the calculator. We're doing very basic graphing ones right now, and then we'll move on to more complicated ones later. All right? There you go. If you have questions, let me know.